In the previous video we did on BinaryReader, the user entered data in this form, 4 fields of data, and it was saved in memory in a list of collections, and then we pressed this button to write it to a file. But what does this file actually look like? If we do a hex dump of the file, you see the first 4 bytes are the first student number, and it's in Little Endian format with the lowest byte having the lowest value. If this were Big Endian format, the lowest value would actually be in the highest byte, chip 03. But we're dealing with Intel chips rather than Motorola chips, so we have Little Endian integers rather than Big Endian integers. And then we have a string that we can actually see over in this part. It says Travis McGee, which is the first student name. And you notice the first character isn't actually a part of the name. The T is actually this 54. You can see it highlighted when I highlight the 54. And this is actually the length of the string, 0C, which is 12 in decimal. And then after the student name, we have a second string that starts here. And you see it's 8 characters. And it's actually the string version of the date of birth, which is 1/1/1948. All these characters just as strings. And the reason we did that is Write understands a lot of different data types, but it doesn't understand date time. So we had to convert it to a string before we saved it. And then it continues on with the same format for the next 4 records. Or the next 3 records, 4 records altogether. So if we compile and run this program, a message box pops up that says the 4 records have been read from the binary file. And these records are displayed in the multi-line list box. And the way we did this when this first starts is the form load event calls the binary read from file button and actually acts as though it pressed this button. So the main thing we want to look at in this video is how does this button work, the code from this button, which is the BinaryReader code. So if we double click on this button, once again we have the usual 4 local variables that we're going to read the data into. And then we have a statement that says if the file exists, then execute this code, which is basically error checking on the level of the read. It's saying if we haven't created this file, obviously we can't read it in. But we do want to do some initialization even if we haven't read it in. So we're going to take the student record count and put that in the number of records and then convert that to a string and put it in the number of records display box. And the reason we do that is we might press this button before we've created the file, but when we do have records in memory. So if there's no records in memory, this will be a 0, which works. And if there are records in memory, this will get the count of the number of records in memory and put that in the text box, which also works. But within the using, which defines the scope of the binary reader, we have a while loop, which is the usual thing of checking if we're at the end of file. But we do something different than the usual while loop in that we have the BinaryReader.pigchar is greater than 0. And the reason this works is as soon as you go past the end of the file, the pigchar will try and look for a byte that isn't there, and since it isn't there, it'll return a -1. So as soon as this returns a -1, we're going to stop looping and displaying records. There's actually a couple different ways we could do this. We could use our old friend the base stream, which has position and length information in it. And we could make a call to the reader name.basestream.position method and check if that's equal to the basestream.length. And if it is, then we need to not loop anymore. Actually, we're saying if it's not equal to it, keep looping, which is the same thing as saying if it is equal to it, stop looping because you're at the end of file. So that's an alternative method for checking for end of stream with BinaryReader. So the main two methods we're using within the loop are readInt32 to read in our 4-byte integer, and ReadString to read in the student name and the date strings. And that's pretty much it. There are, however, a lot of other methods you can use with BinaryReader. For instance, we could just read in all the bytes using readByte and use the base string length to read in all the bytes to a byte array buffer. And then there's other methods such as readChar, which reads one character, readChars, which reads multiple characters, readDecimal, which reads a decimal value, readInt16, readInt32, and readInt64, which read 2, 4, and 8-bit integers. readBoolean, which reads in a value that's interpreted as true or false. readSingle and readDouble, which reads in floating point values, and so on. There's a lot of others. One way you might check with what they are is you can go into the using scope block and say BRE for the BinaryReader object, and then just start typing an R for read, and you'll see the read method, which is sort of the generic method for reading in multiple bytes into a buffer. You specify the buffer size, and readBoolean, readByte, readBytes, readChar, readChars, and so on and so forth. As usual, the auto fill-in is pretty educational. So within the while loop, where we're checking with end of file with the peak char, we do a readInt32 to read in the student number, a readString to read in the student name, and then we need to do a Convert.ToDateTime, and then do a readString to read in the string that represents the date, but then we convert it to an actual date time and put it in a date time variable. So that's sort of a gotcha. You need to handle both ways, writing and reading. And then do another readInt32 to read in the student mark. And then we create a student record, SI, that we initialize with these local variables in the constructor, and add that to the student record list of student info collections. So this essentially adds it to a table of the student info values. And then we increment a variable that gives us the count of the number of records, and pop up a message box that says how many records we read in. So if we run this again, we read in the 4 records, which got put behind the code, unfortunately. And we can at this point add more records. We can say 5 Jack Reacher 5/5/48 average mark of 55, and save that into the memory structure. And then we could display the memory structure, or we can just directly write it into the file with the binary write, and that recreates the file and puts whatever in memory into a new file starting from scratch. And then if we read this in again by pressing this button, we get 5 records read in from binary file, and our new record is there. So it works pretty much the way you'd want it to. Probably want a lot more data if this were any kind of real thing. Well, I hope you enjoyed this video and learned a lot, and I'd appreciate it if you'd subscribe.